Good morning, students. Welcome to my lecture. Today I am going to discuss about binary tree traversals. Before that, let us discuss about binary tree representation. In previous class, I have started binary tree representation, right? Let us discuss that. After that, let us discuss about binary tree traversals. Today's topic is very important, binary tree traversals. Before that, I will discuss about binary tree representation. In previous class, we have discussed about that, right? Let us discuss binary tree representation. First, let us discuss about what is meant by binary tree. Already you know that. Let me recap for 10 minutes. See, binary tree, it is also non-linear data structure. I'm sorry, it is a non-linear, not linear. Binary tree is a non-linear. It's not linear. Just wait. I will erase this thing. Non-linear. Non-linear. Okay, see here. Binary tree is a non-linear data structure. You know that what is meant by non-linear data structure, right? Non-linear data structure means elements are not arranged in some linear fashion. Okay, it will occupy some random positions. It is a non-linear data structure with at most two children. At most, not at least. Please don't get confused. At most. It is a non-linear data structure with at most means not more than two children. Let us see. See, for example, A. See, a node may contain one child. It is a binary tree only. See, a node can contain one child. A node can contain two childs. See, a node can contain one child or a node can contain two child. But see here, node should not contain more than two childs. That means this is not a binary tree. Why you are saying this is not a binary tree? Because see here, node A, parent node. A is a parent node, right? This is a parent node. Here B, C, D are child nodes. Here the node parent can have one child. Parent A can have another child, but it should not contain three childs, four childs, five childs, so on. It should contain only two childs or one child. That's all. It should not contain more than two childs. This is wrong. This is not a binary tree because parent A contains parent A has three children. It should contain only two or one. That's all. I hope you understood, students. This is called binary tree. Now, let us see how to represent this binary tree in memory representation. In previous class, we had discussed about this, right? Let me recap for 10 minutes. Here, binary tree can be represented in two ways. Binary tree can be represented in memory. How will you represent binary tree in memory? In memory, here binary tree is represented in two ways. First one is using arrays. You can represent the binary tree using arrays. Second one, using linked list. Using linked list. Using linked list, you can represent the binary tree. Using arrays, you can represent the binary tree. Okay. Now let us see how to represent the binary tree using arrays. Let us see it. I request all the students to maintain the running notes and write down example 2. In previous class, I have explained example 1. Now example 2. How to represent binary tree using arrays. Let us see it. Write down example 2. This is a binary tree. See here, every node contains two children or one children. Okay, this is called binary tree. It should not contain three children. It should not contain four children, like that. It should contain only two children or one children. But it should not contain more than two children. Every node should contain two children or one children. It should not contain more than two children. Okay, more than two. If it contains three children, this is not a binary tree. Now see here, this is a binary tree only. See every node. See, node 20 had two children. Okay. Node 10 has two children. Okay. Node 23. Node 23 has one child. Okay. It is a binary tree only. It may contain one child or two childs. It is a binary tree only. Now, example 2. Write down, note down, students. Example 2. Draw the tree, binary tree. Here, what is the root node? 20. Root node. This is a root. Root node. 20. Child nodes are 10, 23. Next. Here, parent node is 10. Child nodes are 8, 15. Like that. Now, I hope students, please note down, students. I request all the students to note down. Example. Now, let us see. First step. First, you need to know if you want to represent this tree in array. If you want to represent this tree using array, first you need to know array size, right? You need to declare the array, right? If you want to declare the array, first you need to know size of the array, how many memory locations it should occupy. Okay, you should know, right? How to know it? See, first step, size of array. Size of array. Size of array is 2 power h plus 1 minus 1. Here h means height of the tree. What is height of the tree? It is nothing but see the longest path. See the longest path. What is the longest path here? See here. Either this one or this one or this one. This is the longest path, right? How many links are there in this longest path? 1, 2. 2 links. So height is h equal to 2. Height of the tree is nothing but you need to see longest path. In that longest path, count number of links. Links are nothing but solid lines which connect the parent and children. Count that links. Here, how many links are there? See, 1, 2, 3. 3 longest paths are there. Both are same. Here, number of links are 2. So, height of the tree is 2. Or you can say like this. Or like this. See, level 0, level 0, level 1, level 2. What is the last level here? What is the last level? 2. So height of the tree is 2. You can say like this also. Last level is nothing but height of the tree. Here level 0. Level starts from 0. Level 0. Level 1. Next level 2. 2 levels are there. So height of the tree is 2. Now let us compute the size of the array. Size of the array. That implies 2 power 2 plus 1 minus 1. That implies 2 power 3 minus 1. That equal to 8 minus 1. That equal to 7. Now size of the array is 7. Write down. I request all the students to note down. This is not a theory part. Don't listen. Listen and write down. Not only listening, listen and write. Note down. This is not a theory part. Data structure is not a theory part. You need to solve the examples by using algorithms. Step by step. It is not a theory subject. By listening, you can't get anything. You need to note down. You need to practice the algorithms. You need to solve the examples. First step, note down the size of the array. What is the size of the array? 7. So, how many locations will be there? Sorry. See, how many locations will be there? 7 locations. Here, index starts from 1. Okay, index starts from 1. If index starts from 0, formula will be changed. Remember that. If index starts from 0, formula will be changed. Which formula I will say? Just wait. Index starts from 1, 2, 3, 4, 5, 6, 7. Size is 7, right? So how many locations will be there? Continuous memory locations, 7 locations will be there. Write down. 1, 2, 3, 4, 5, 6, 7. Index starts from 1. Now, second step. Step by step you have to note. Second step. What you need to do? You need to insert. You need to, students, step by step you need to write. This is step 1, step 2. Step 2. Insert a root node. What is the root node? Superior node. See here, 20. 20 is a root node, right? Insert root node 20 in where it, one second. Here, name of the array is a tree. Where node 20 must be inserted in first location. Insert node 20 in location tree of 1. Tree of 1 means first index. First index. First index. See, step by step, please note down. I won't say step by step, but you need to write down step by step. 1, 2, 3, 4, 5, 6. See, notes also there is no step by step, but you need to write down step by step. See here in notes, I have represented in only one step. See here, only one step. But in examination, you need to write down step by step. First step, insert 20. Second step, insert 10, like that. Okay. Step by step, please note down. Now 20. 20 must be inserted in first location, completed. Second step is completed. Next, see here, 20 completed. Next. Now, you need to insert 10. What is the 10? Left child. To insert a left child, there is a formula. What is that formula? Let us see. Next, step 2. Sorry, step 3. Insert, step by step. Note down step by step. Insert left child of 20. In which location? In C here. There is a formula 2 into I. 2 into I. 2 into I means here I is nothing but parent location. What is the parent of 10? See here. See here. See. What is the parent? Parent node of this one. Node 10. Parent node of node 10 is 20, right? So where 20 is present? In which location? See in array. In which location 20 is present? In first location. So I equal to 1. 2 into 1, that implies 2. Now 10 must be inserted in second index. Again draw the diagram. What diagram? Array. See, I'm not going to explain step by step. You need to write step by step. Okay. Again draw the diagram, array diagram, and insert 10 in second location. Second location, insert 10. Again draw, students, in step 3. Again draw this array. Don't write in one step only. Here I'm explaining in only one step. Okay. Now, fourth step. What is the fourth step? Step 4. You need to insert right child. See here. See, 1 second. Students, 1 second. See here. Here, actually, you need to insert from first insert a root. I'm sorry. See, first insert a root. After inserting root, come from left, level by level. Come level by level, left to right. 20 completed. Next, you need to insert 10. Next, you need to insert 23. After completing this level, come to next level, left to right. Next, you need to insert 8. Next, you need to insert 15. Next, you need to insert 40, like this, okay? You need to come level wise from left to right. Insert the nodes from left to right, like that you need to insert. Now, see, in one step only I am explaining. 20 is inserted here. But write on step by step. Next step. 20 is inserted, 10 is inserted here. Next. See, you have to write down step by step, but here I'm explaining in only one step only. 1 second. See, in one step only I'm going to explain, but you write down in step by step. You need to note step by step, okay? In examination also, you need to write down step by step. In notes, I have represented only in one step. But in examination, write down, please note down one step by step. Just wait, I will draw array. 1, 2, 3, 4, 5, 6, right? One, 2, 3, 4, 5, 6, 7. Again, other is needed. Just wait. So I'm explaining only one step. You note down step by step. 4, 5, 6, 7. Okay, 10, 20 completed. Next 10 completed. Now you need to insert which node? 23. Now, if you want to insert 23, 23 is a right child of 20. If right child means what is the formula? Right child. See, step 4, you need to note down like this. Step 4, insert 23. 23 is the right child of 20. If right child means write down the formula. 2 into I plus 1 position. In this position, you need to insert. Now, I is nothing but here I is a parent position. What is the parent node of 23? See the diagram. See the tree. See the tree 23. This is 23, right? What is the parent node of 23? 20. 20 is the parent node of 23. Now, see the position of 20. What is the position of 20? First index. Now, here 2 into I means 2 into 1. Here I is nothing but parent node index. Now you are inserting 23. You are inserting 23. 23. 23 parent is 20. Now 20 node index. What is 20 node index? See the array. See the array. In array, parent node of 23 is 20. 20, see here. See the diagram. This is the diagram, right? 20. 1 second. See the index. Index of 20 is 1. Okay. Now 2 into 1 plus 1. 2 into I plus 1. 2 into 1 plus 2 into 1 plus 1. 2 plus 1 that equal to 3. In third position, you need to insert 23. It's very simple. See here. I will write the formula here. Left child. Left child. You need to insert left child in 2 into I position. Here I is the position of parent node. Position of parent node or index of its parent node. Right child. Right child position must be 2 into I plus 1. In this position you need to insert. Now next one. 10 level 0 completed, level 1 completed, 10 23 completed. Next level. What is the next level? 8. Come from left to right. You need to insert 8. 8 must be inserted in which position? 8 is the left child. Left child of 10. Left child means 2 into I. Left child 2 into I. I is nothing but parent's node position. What is the parent node of 8? 10, right? See, what is the parent node of node 8? 10. This one, 10. Now see, what is the index position of 10 in array? See here, see the diagram. 2, right? See this one. 2. So, 2 into 2 that is equal to 4. Now you need to insert 8 in fourth index. You need to insert 8 in fourth index. So insert 8. Completed. Now 8 completed. Next. Come from left to right, level by level. 15. You need to insert 15. 15 is a right child, right? Right child means 2 into I plus 1. Here I is nothing but its parent's position in array. What is the parent node of 10? Sorry, parent node of 15. We are inserting node 15, right? What is the parent node of 15? 10. Parent node of 15 is 10. Okay, just wait. Now, what is the index of parent node 10? 2, right? See the array. It's a parent. 15 node parent is 10. Now 10 element 10 index. What is element 10 index in array 2? Now you need to insert 15. In which position? 2 into I. I is nothing but 10 node 10 position 2. 2 into 2 plus 1 that equal to 4 plus 1 that equal to 5. Now in fifth position you need to insert 15. Completed. Step by step you need to note down. Next step, 15 completed. 15 node completed. Next, 40. You need to insert 40. In which position? See here. 40 is a left child or right child? It is a right child, not left child. Right child means 2 into I plus 1. Right child means 2 into I plus 1. I is nothing but parent node index. What is the parent node of 40? 23, right? See the diagram. See the tree. Parent node of 40 is 23. Now see the index of 23 in array. What is the index of 23 in array? 3. So now 40 must be inserted in 2 into 3 plus 1, that implies 6 plus 1, that implies 7. In 7th position you need to insert 40. Completed. Okay, I hope you understood, students. 2 into I plus 1. Note down the formula. 2 into I plus 1. Right, child? 1 second, again I will write. Left child means 2 into I position. Right child means 2 into I plus 1 position. I hope you understood, students. This is the example 2. Now let us see how to represent this same binary tree. Same binary tree in linked list representation. Let us see how to represent same binary tree. Write down second one. Note down, students. Second one. What is second one? What is this? Just wait. Second one, representation of binary tree in using linked list. Using linked list, you can represent this binary tree in memory. How to represent it using linked list? Let us see. Same tree. Keep the heading second one using linked list. Keep the heading using linked list. Now, don't draw the diagram. Don't draw the diagram. First, keep the heading using linked list. Now, here, each node, if you want to represent this tree in linked list, each node consists of how many fields? See here. First, you need to write on the linked list. What is meant by linked list? Linked list is nothing but it is a collection of nodes. Now, let us see. Here, coming to binary tree, linked list of binary tree consists of how many fields? 3 fields. First field is left field, LEF, left field. Next is a data field. Next is a right field. Here, left is a pointer, which contains, you need to note down. Please note down. To represent the binary tree, note down, to represent the binary tree using linked list, each node consists of how many fields? 3 fields. First note down the diagrammatic representation of node. Diagrammatic representation of node. Draw the node. After that, note down, each node consists of how many fields? 3 fields. First field is a left field. Next one is a data field. Next one is a right field. Here, left is a pointer which contains, note down, which contains address of left child. Address of left child. Left child address, or left node, or left child, whatever it may be. Next, data. Next one is a data. Data field consists of elements. Element. Next, right. Right is a pointer. Okay, it is a pointer which contains at the same thing. Write down. Here, right field is a pointer which contains address of right child. Note down. Draw the diagrammatic representation of node. Each node consists of how many fields? 3 fields. First field is the left field, which is a pointer. In programming, you need to represent like this, star left.
Ma'am, your voice is not audible. Ma'am,
Hello, students, is my voice is not clear?
now it is clear, ma'am.
వినపడట్లేదు. ఎప్పటి నుంచి? స్టూడెంట్స్, వాయిస్ వినబడట్లేదా? ప్లీజ్ రెస్పాండ్.
Now it is clear, ma'am.
హరిప్రియ, హరిప్రియ,
Ma'am,
ఎప్పటి నుంచి వినబడట్లేదు వాయిస్?
మ్యామ్ 3 ఫీల్డ్స్ చెప్పారు మ్యామ్. తర్వాత నుంచి మ్యూట్ అయిపోయింది.
ఏంటి?
3 ఫీల్డ్స్ చెప్పారు మ్యామ్.
అప్పటి నుంచి వినబడట్లేదా?
దాని తర్వాత నుంచి మ్యూట్ అయిపోయింది మ్యామ్.
ఓకే, ఓకే. Sorry for the disturbance, students. See, each node consists of how many fields? 3 fields. Left field, data field, and right field. Okay, left field, data field, and right field. Here, left field is nothing but pointer which contains address of which node? Left child node. I'm sorry for the disturbance. Left child node. And data is nothing but it contains value. And the next one is right. Next one is right. Okay, right is also a pointer which contains address of right child. Now how to represent using structure? See, you need to declare structure. Struct space node. Is it clear now? Just wait. Okay, just wait. Okay, see how to represent using structure. Struct space node. Next, struct node star left. Next field is a data field. Data field contains which data field contains element, right? Elements are nothing but integers. Int space data semicolon. Next, right field is also a pointer which contains a which contains address of right child. Okay, right child, that means it points to node only, right? It points to node only. That's why struct node star right. Okay, after closing, see, after closing here, what are the structure members? Structure members are left, data, and right. If you want to access left, data, and right, if you want to access left, data, and right, you cannot access directly. Here, left, data, and right are called structure members. All the variables which you have declared inside structure are called structure members. Now if you want to access this left, data, and right in your program, you cannot access directly into your program. Then how to access? If you want to access these structure members, you need to declare a structure variable. What is structure variable? Where you need to declare? See here, after closing the structure, here see star, here I have declared pointer star root. Here root is nothing but structure variable. Using root only you are going to access, like this: root of left, root of data, like this you are going to access, root of right. See, root arrow mark. See, if you are using here, I have declared a pointer, right? Here structure variable root is a pointer. That's why if you want to access the structure members like left, data, right, you need to use arrow mark. If you are using star, okay, if you are using pointer, simply without pointer, if you are using root like this means you need to use a dot operator, root dot left like that. If you are not using pointer means, okay, if you are using pointer means you need to use arrow mark, not dot operator. Root arrow mark left, left, root of data, root of right. Okay, is it clear, students? Next one. Next. Now let us see. Same I will represent using linked list. Note down, students. Please note down struct node. Just wait. Okay. Now see here. Please note down this example. Note down this example. Now let us see linked list representation. Let us see linked list representation. Linked list representation of same tree. Let us see it. Draw, everyone. Please draw. Each node consists of how many fields? 3 fields. Left field, data field, right field. Right field. Note down. Next. 10, 23, 23 right, 40. This is null. See, if node does not contain any child means keep null. Right child 15, null. Left child is 8, right? 8. This is null. Write down, students, null. Okay. This is the linked list representation of this binary tree. Each node consists of how many fields? 3 fields. Left points to left child node. Right points to right child node. Middle one is a data field. This is the linked list representation. Please draw. See, if there is no left child means keep null. If there is no right child means place null. Null means nothing. Right pointer points to right child node. Left pointer points to left child node. Is it clear, students? Is it okay? Only one member is responding. Is it clear? Is it okay? Okay. Okay, Sirisha, Haripriya. I hope you understood. Now let us see. Let us see tree traversals. This is very important topic. Tree traversals. Keep the heading tree traversals. Binary tree traversals. Binary tree traversal. Keep the heading binary tree traversals is very important. I'll explain. Binary tree traversals. BR binary tree traversal. Okay, see here. Binary tree traversals. Just wait. Okay, see. Tree traversal. Traversal means accessing each and every node. This is a tree. A, B, C. This is a tree. Here, traversing the tree means accessing each and every node, visiting each and every node in the tree. It is called traversing. Traversing means visiting each and every node in the tree is called traversing. Now, here there are tree traversal techniques. Here there are 3 traversal techniques. First one, note down. Don't draw the diagram. Don't draw the diagram. First, keep the heading binary tree traversals. After keeping binary tree traversal, please note down the definition. Traversal means accessing or visiting each and every node in the tree. It is called tree traversal. Tree traversal means just wait. I'll write visiting or accessing each and every node in the tree. In the tree is called tree traversal. There are three tree traversal techniques. There are, note down, there are three tree traversal techniques. Three tree traversal techniques. First one is pre preorder traversal. Preorder preorder traversal. First one is in order, right? I'm sorry. First one is in order. Just wait. First one is in order. In order traversal. In order traversal. In order. Second one is pre-order. Pre-order. Third one is post order. Post order. Here, note down. There are three traversal techniques. First one is in order traversal. Second one is a pre-order traversal. Third one is post order traversal. Now let us see in order traversal. Please note down. There are three traversal techniques: in order, pre-order, post-order. Now let us see in order traversal technique. First, I will explain the procedure and then later I will explain algorithm. Okay. In the next class, I will explain algorithm. Now let us see only procedure and how to solve it. First one, procedure. Procedure. Procedure is first one. Here, procedure of in order. In order. First, what you need to do is, uh, 1 second. Traverse left subtree. First let us see 1 second. First let us see pre-order. It is easy, right? First pre-order is easy. Okay, I'm sorry. Pre-order. First pre-order. Let us see, sorry. Pre-order will be easy. Pre-order. First let us see pre-order. Pre-order. First what you need to do is visit a node, root node. Visit a root node. Visit a root node. Second one is traverse left subtree. Note down left subtree in order. In order. Third step, traverse right subtree in order. In order. See here, write down the procedure. First what you need to do, you need to visit the root node. Here traversal is nothing but accessing each and every element or visiting each and every element. Here you need to visit, you need to write down the order in which order you are going to visit these nodes. First one, in which order? Pre-order. I'm talking about pre-order. First one, visit root node. Second step, traverse left subtree in pre-order, right? Again, pre-order. I'm sorry, pre-order. We are talking about pre-order, right? I'm so sorry. Pre-order, not in order. See, traverse left subtree in pre-order. I'm so sorry. Here I'm talking about pre-order, right? Okay, see, this is the procedure. Visit root node. Next one is a traverse left subtree in pre-order. Next, third one, again, traverse right subtree in pre-order. Let us see it. Let us see it. Please note down, visit root node, traverse left subtree in pre-order, traverse right subtree in pre-order. Now I will explain. In the next class, I will explain the algorithm, okay? In the next class, I will explain the algorithm. Now, I will explain how to solve it. In the next class, I will explain according to the algorithm by tracing the algorithm. Now, let us see how to solve this. Now, here you need to write each and every node in pre-order. How to do it? First, shortcut. See, I will explain in shortcut. First, remember L, C. L R. Remember L R. L means traverse left subtree. R means traverse right subtree. Here pre-order, right? Pre means before. So write down V before LR. I am explaining in shortcut in next class. In next class I will explain according to the algorithm. Okay, here VLR. Remember VLR. V means visit node. L means traverse left subtree. R means traverse right subtree. First, for every order, for every pre-order, in-order and post-order, please remember LR. L means left subtree. R means right subtree. Now, see here, you are using pre-order, right? Pre means before. So, write down V before LR. So, what is the shortcut for pre-order? VLR. Now, see, for every node, for first start from root node, write down VLR. Here, V means what? V means what? V means visit node. So visit A. Here you need to write down visited nodes A. Next, what is the next step? We completed, right? Please strike it off. We completed. Next, what is L? L means you need to go left subtree. So strike it off and go to left subtree. Left subtree, this one. At now VLR at node B. This is a left subtree, right? See, this is a left subtree. This is a left subtree. Now at node B, write down this shortcut. I will explain later according to algorithm. First, let us see. Let us see how to solve it. VLR. What is V? First one, what is V? V means visit. Visit node. So you need to visit B. Strike it off. After visiting, strike it off. Next, what is the next one? V completed. L, right? L. Okay, we are at B, node B. L. L means go to left. Strike it off. After going, strike it off. VLR. So go to left subtree. What is left subtree? There is a D. At node D, write down VLR. What is V? V means visit node. What is node? Root node. Visit node. What is node? D. Write down D. After completing V, go backtrack. There is no left child, right? See, after V completed, next what you need to do? L. At this node only, at a node D only. L next. L, there is no, it is null. There is no another node. Strike it off. Next, what is the next step? R. You need to go to the right subtree, but here there is no right subtree. At D, there is no right subtree. So, you need to strike it off and go backtrack. Now go backtrack. Come to node B. Backtrack. Okay. V completed. L completed. R. R means you need to go to right subtree. Strike it off. Write down at right subtree. Right. Come to right side of B. Note down V L R. V means visit node. So write down E. Strike it off. After visiting, this is shortcut. Later I will explain according to the algorithm. Strike it off. Write down V means visit node E. After V completed. What is L means go to left subtree, but there is no left subtree. No need to go anywhere. Next, L completed. Next, R means again you need to go right subtree of E. There is no right subtree of E. So there is no right subtree. Now you need to go backtrack. Go to B. Backtrack. Go to B. Completed. V L R completed. Go to backtrack. If completed means backtrack. Go to A. Backtrack. Just backtrack. Go to A. V completed. L completed. R. R means you need to go to the right subtree. What is right subtree? This one. CF, right? Come to this node C. Write down VLR. VLR. V means what is V? V means visit. Completed, right? Visit. You have visited. If completed means strike it off. Next. What is the next one? L. You need to go to the left subtree. Left subtree is F. There is only F. V, L, R. V means visit F. Okay, next L. L means there is no left subtree. No need to go anywhere. Next, what is the next one? R. R means go to right subtree. There is no right subtree. So backtrack. Go to backtrack. Completed, right? VLR completed. There is no left subtree. There is no right subtree. If there is left subtree, you need to go to the left subtree. But here there is no left subtree. There is no right subtree. Backtrack. That means go to C. Backtrack. Go to C. V completed. L completed. R. There is no right subtree. So this is the visited nodes A, B, D, E, C, F. This is a visited node. Visited nodes. I hope you understood, students. Again, in the next class, I will explain according to the algorithm. I will trace the algorithm and then I will explain. This is just a shortcut. Just I'm explaining how to solve it in a shortcut. In next class, I will explain according to the algorithm. Is it clear, students? Once again, should I explain it? Students, please respond. Did you understand? Once again, shall I explain? Did you understand? Clear? Haripriya only is responding. Remaining members Pranita, Sirisha, Mahesh Babu, Teja, Haripriya. Okay. Teja, Teja, are you there? Is it clear? This is just a shortcut. In later class, I will explain. Now, next. Next. Now for this tree, one second, pre-order, right? We are discussing about pre-order. Yes. Okay. Next example. This is your homework. This is your homework. Next example. Note down. This is your homework. Note down this tree. Note down this tree. 11, 6, 19. Note down. This is your homework. You need to do the pre-order. That means just write down visited nodes only. Okay, here pre-order traversal means you are visiting each and every node. In which order you are visiting, that you need to note down. That is a solution. Just like this. See here. Visited nodes A, B, D, E, C, F. Note down 11, 6, 19. This first one is 11. This one is 11. Next 6. This one is 6. Next 19. Next 4. This one is 4, 8. 4, 8. First 11, 6, 19, 4, 8. Next level, this one is 1743. 1743. Next level nodes are 5, 10, 31, 49. Please note down, this is your homework. See, tomorrow class, I will call the roll numbers. You need to answer in which order. Okay, pre-order, you need the solution of this one. This tree, you need to answer it. 11, 6, 19, 4, 8, 17, 43, 5, 10, 31, 49. Okay, now let us see in order. Let us see in order. Note down in order. Note down in order. In order. Procedure. In order. Is this tree is completed? Please answer. Is it completed? Shall I continue? Students, shall I continue? Please note down this tree. Please note down this tree. This is your homework. You need to do this very, very simple. Please note down this tree. 11, 6, 19, 4, 8, 17, 43, 5, 10, 31, 49. Please note down. This is your homework you need to do. Now, let us see in order traversal. In order, first one. See, always remember LR. Okay, always for this in order, pre-order, post-order, always remember LR. L means left subtree, traverse left subtree. R means traverse right subtree. Here, what is the name? Name. See, in order, in. In means middle. So, just I'm explaining in shortcut. L, keep visit in middle of LR. Okay. See, always remember this is just a shortcut to remember. L means left subtree, R means right subtree. Here, what is the order we are doing? In order, in. See, in itself, it is saying in. In means middle. That means place visit in middle of LR. LVR. Shortcut for in order is LVR. Shortcut for pre-order. Always remember LR. Pre-order means pre means before, right? Write down V in before LR. This is in order. This is pre-order. For post order, always remember LR. L means left subtree. Traverse left subtree. R means traverse right subtree. Post. Post means after, right? So after LR, place V. Now shortcut for post order is LRV. V means visit. Okay, these are the shortcuts. Now let us see the procedure. First, note down the procedure. Algorithms I will explain later. In the next class, I will explain algorithms. First one, LVR, right? L means a traverse. Traverse left subtree. Note down the procedure. Traverse left subtree. I'm talking about in order. In order shortcut is always remember LR. So now where you need to place visit? In means middle. So LVR. Middle of LR, place visit. V. This is just a shortcut LVR. L means traverse left subtree in order. In order. Second one, visit root node. Visit root node. Third one, traverse right subtree. Right subtree in order. This is the procedure for in order. Traverse left subtree. Note down shortcut also. What is the shortcut for in order? LVR. Traverse left subtree in order. Traverse next one is visit root node. Next one is traverse right subtree in order. Now let us see with an example. First note down the procedure. In later class I will explain the algorithm. Note down the procedure, students. LVR left subtree, traverse left subtree in order. Next one visit root node. Next one traverse right subtree in order. Note down. Now let us see how to solve it. In shortcut I will explain. In the next class I will explain according to the algorithm. Okay, remember the shortcut. Now LVR, right? Shortcut LVR. Now A, note down A, B, C, E, F, something like this. Now see. First start at root node. Just I am explaining in shortcut. Later I will explain according to the algorithm. L, V, R. Okay. Here what is meant by L? Traverse to the left subtree. After traversing, strike it off. Come to here. Left subtree. This is left subtree, right? What is the root node for this left subtree? B. Now come to B. Come to B. At node B, write down LVR. At node B, write down LVR. LVR. Okay. Now, what is the first step? L. L means go to left subtree. Again, go to left subtree. Okay. Left subtree. What is the node? Root node here? Left subtree. D. LVR. L means go to left subtree. There is no left subtree. It is null. After D, there is no left subtree. There is no left subtree means next. What is the next step here? V. Visit D. Now, what is the visited node? Write down visited node D. Okay. After D, what is the next step? R. R means you need to go to the right subtree. There is no right subtree. Null. If there is no right subtree means next step, backtrack. LVR completed. Backtrack. Backtrack. Go to B. Node B. What is the next step? V. V means visit B. Write down visited nodes. After V, what is the next step? R. R means you need to go to the right. Come to right subtree. L, V, R. Okay. L means you need to go left side, but there is no left child. Left child. There is no left child. Now, next step. What is the next step? V. V means visit E. Visit E. Next. What is the next step? After V completed R. R means you need to go to the right. There is no right child. So completed. LVR completed. Backtrack. Go to B. In B, all the nodes are completed. Sorry, all the steps LVR completed, right? So backtrack. Go to A. So what is the step remaining? V means visit A. Write down visited node A. After V, what is present? R means you need to go right side. Go to right subtree. L, V, R. L means you need to go to the left. See here, you need to go to the left subtree. There is no left child. There is no left child. So what is the next step? V means visit C. Note down C. After visiting, please take it off so that you will understand what is the next step. Okay, LV completed. Next R. R means you need to go to the right subtree. Go to right subtree. LVR. Now see, L means you need to go to the left. There is no left child. Left child. There is no left child. So what is the next step? V. V means visit F. After visiting, what is the next step? R. You need to go to the right subtree, but there is no right subtree. LVR completed. Backtrack. So come to C. Steps are completed. LVR completed. Backtrack. Come to A. LVR completed, right? So this is the visited nodes D, B, E, A, C, F. In the next class, I will explain according to the algorithm. This is just a shortcut. This is very easy, students. Please practice it. Okay, is it okay? Is it clear? Students, did you understand today's class? Tree traversal techniques. Please respond. Did you understand today's class? Haripriya, Teja, Sirisha, Pranita. Please practice. Write down example 1 for pre-order. For pre-order. 1 second. Note down this one, not this. Students, please note down this. Note down this one, this tree example. You need to practice these examples. A, B, C, D, E, F, G. Next, H, I, J. J is the left child of E. Please note down, you need to practice it. Tomorrow's class, I'll ask the answer. You need to respond, otherwise I will keep absent. Your wish. Today's your assignment, your work is you need to practice. You need to solve this example in order and pre-order. Please note down, students. Root node A. Next one is B, C, child nodes. Next D, E, F, G, H, I, J. Today I have explained only shortcut and procedure, right? In the next class, I will explain according to the algorithm. Once again, let us see algorithm. I will trace it out and I will explain. Okay, students, thank you.